Srinivasa Ramanujan was an Indian mathematician who made substantial contributions to mathematical analysis, number theory, infinite series, and continued fractions, despite having no formal training in pure mathematics. His work has had a considerable impact on various areas of mathematics, and he is considered one of the most influential mathematicians of his time. Given the complexity of his work, I'll provide a detailed explanation of his formula for pi, which is one of his most famous contributions. This formula is a rapidly converging series, meaning it quickly approaches the true value of pi. Here it is: 1 pi 2, 2, 9801, 4k, 1103, 2639 kk, 4396, 4k. This formula is an example of a modular equation, and it was one of the first examples of a connection between number theory and the theory of special functions. It's a special case of the general class of formulas, known as hypergeometric series. To understand this formula, we need to understand several mathematical concepts. Factorials k. The factorial of a non-negative integer k is the product of all positive integers less than or equal to k. It's denoted by k. For example, 5, 5, 4, 3, 2, 1, 1, 2, 0. Summation. The summation symbol is used to denote the sum of a series of numbers. The series is often expressed in terms of a variable like k, in this case hypergeometric series. A hypergeometric series is a series whose terms are fractions with factorials in the numerator and denominator. Ramanujan's formula for pi is an example of a hypergeometric series. Modular equations. These are a type of equation that come from the theory of modular forms, a branch of number theory. Ramanujan's work on pi was one of the first connections between number theory and the theory of special functions. Ramanujan's formula for pi is remarkable for several reasons. First, it converges extremely rapidly, which means that even the first few terms give a very accurate approximation to pi. This was useful in the early days of computers, when computational resources were limited. Second, the formula connects several different areas of mathematics: number theory, the theory of special functions, and the theory of series. This was a common theme in Ramanujan's work, and it's one of the reasons his work is still studied today. Finally, the formula is an example of Ramanujan's incredible intuition for mathematics. He had very little formal training in mathematics, yet he was able to discover results that baffled many of the leading mathematicians of his time. His formula for pi is just one example of his extraordinary mathematical insight. That's going to do it for today if you stuck around to the end. Don't forget to like and subscribe, got a lot of cool stuff coming your way that you won't want to miss.